Hi, I'm Tom Steffen with Goulds Water Technologies. Today we're going to cover a basic duplex panel and a variety of different floats. So let's start with this panel right here. This is a D120. First thing to note, the clear cover. So this is for demonstration only and does not come with a clear cover. So let's take a look at the model number D120. That is D for duplex, 1 for single phase, and the last 4 numbers are your current. So in this case, handles from 0 to 20 max amps. So we can see a lot of that repeated here. We have an SCS series duplex, 115 or 230, so that's one nice option here. These panels are multi-voltage, single phase, 60 hertz, 20 amps max, as the model number indicates. Okay, so next let's take a look at, we have 2 run lights, pump number 1, pump number 2, and an alarm test. In this case, we want to test the alarm, a horn silence, and an alarm reset. So now let's take a look at the inside of the panel. Okay, so now let's actually operate this panel with our 3 float switches. So first thing I'm going to do is check my circuit breakers are on. My control panel is currently off, so I'm going to turn that on. Let's take a quick peek at the hand. So right now they're off, hand. So we can see pump number 1 is running. Turn that off. You can manually run pump number 2. So that is hand or manual. Let's flip those both to automatic. Okay, automatic means that I'm operating off of my floats. So I have a 3 float system, and this is my off float with my weight in this case, and my on float, and my 3rd float is my alarm. And so typical 3 float system, again, you can wire this up for 4 float, and there's other variations, but let's just review the basic 3 float system. So as the water level rate rises, the off float goes on. We can see the corresponding LED through the panel. Nothing happens other than the light. And now the on float floats up, and my light goes on, and pump 2 is running. Let's just say pump 2 does the job, and notice nothing happens until the off float goes down, and now pump 2 goes off. So next time we need some pump operation, let's simulate that. Off float goes up, on float goes on, and now it's automatically alternating, so pump 1 is running now. All right, so pump 1 does the job, and then turns off pump number 1. Another scenario is that, let's say pump number 2 in this case, going to call for pump number 2 this time. Let's say that pump number 2 is not able to keep up. So let's simulate that, and let's get to the 3rd float. So the off float, the on float, pump 2, and again, we're just simulating that pump 2 is not able to keep up, and the way it's wired now is the alarm goes off, telling you something's wrong, and pump 1 comes on. So let's say that with both pumps on, it does the job, turns the pumps off, but the alarm is still going. So we have to manually reset that. So with your panel, you will get a wiring diagram. So I just want to highlight a couple footnotes here that are very important. Let's start with the top here. For 120 volt operation, use terminals L1 and N, and you need to jump N and L2. So very important there. So that's for 115 or 120 volt operation. The second thing is very important also with a 230 volt system. You can see here highlighted, 230 requires a neutral basically. And if you do not have a neutral, you're not going to power up the panel. So very important with 230, you have to have a neutral to apply power to the panel. The next footnote here, we're going to skip alternator switch because we're going to actually show you on our demo panel. The next footnote here is for separate 120 volt AC control. So we're talking about down here, see footnote 1. So this is in certain areas, there's code that requires a separate power supply, 120 volt powering the panel, and again separate from your primary feed. So that's what this is referring to. If you have a separate 120 volt power supply, you remove jumper J1 from terminal H and L1, connect a 15 amp max to terminals L1 and N with the neutral of the supply. So again, this is for a separate 120 volt supply. So the last footnote here is number 3. It's factory wired for 3-float operation. So for 4-float, you want to remove jumper J2 from terminals 6 and 8. So we can see here, here's my J2, 6, and 8. So you want to remove that jumper and install the lag float on 5 and 6. So next, let's discuss and show the operation of the alternator switch, which is here, and factory preset to the middle position, and you have the option to change it to pump number 1 all the way up, pump number 2 all the way down. So let's set it to pump number 1, and what we're going to do is we're going to simulate that we have a problem with pump number 2. Therefore, we want this panel to always call for pump number 1. All right, so let's take a look. We've got the alternator set to number 1. So we're simulating that pump number 2 is out for repair. We've pulled it, and we do not want the panel to alternate or to call for pump number 2. So we've moved it to position 1, and let's just see how that works. So wastewater is rising, pump number 1 is working, but to make sure that it doesn't alternate, let's just do it again. Pump 1 turns off, level rises again, and does not alternate and continues to call for pump number 1 because of our alternator switch set to 1. So there's many different types of floats or switches, which we seem to use those two terms interchangeably. Two basic types are pump switches, which are designed to handle the amperage of the pump, and then panel switches that are not designed to handle the amperage of the pump because they're directly wired to the panel. A couple other varieties, categories are pump up and pump down, which we have a couple examples here, and we'll talk about that. In many different varieties of floats or switches, could be a vertical switch, could be a diaphragm switch. So we've got a variety here that we're just going to go through and talk about the type of switch that it is, and we're also going to put the meter to it to maybe help us understand what type of switch it is. So now let's move on to the floats. There's many different types of floats, and so today we're just going to cover some of the different varieties and also just cover how to use a multimeter and testing your float switches. So let's first review some of the information they have on the Wastewater technical manual. that can be found on Goulds.com. And let's focus on just the switches. So let's take a look at, in this case here, page 27, switch diagrams. So occasionally you need to know how to direct wire a switch, and of course through a junction box. So there's a couple good diagrams with that, one for a single float and another for a double float. So let's talk about pumping range. And pumping range is the distance between on and off. Notice one thing here too, that the off point is, the pump is covered with liquid. So that's very important that to maintain your cooling. So that's one tip when adjusting your tether length and your switch position. So how do I adjust my pumping range? You go here to this chart and you could see tether length on the vertical, pumping range in inches on your horizontal axis, and as your tether length increases, the pumping range increases. Also on this page is how to correctly use the mounting strap that is supplied with some switches. And we're going to show you exactly how that's done. But as this picture indicates, you come straight down and then horizontally through, and it's attached to the pipe here with your strap. Next is a piggyback, and we're going to take you through how to test a piggyback switch with a multimeter if you ever wanted to do that. So now let's talk about some different types of switches. And, you know, what can we tell by looking at the switch, and also information on the tag, and we'll also put the meter to it. So this is a demo switch here. It's clear so we can see what's going on inside. So a couple things that we can tell is that the contacts are open. So this is a normally open switch, and as the switch floats up, the contacts close. As the ball floats the other way, contacts close, turns the pump on, and the liquid goes down. So this is a normally open or pump down. So both of those are the same thing. So normally open is a pump down switch. The other thing that we can see, it's a piggyback design. So this plugs into the outlet, and we can see it's 120. And the pump plugs into the back of it. And so the whole idea there is if something goes wrong with a switch, you can easily take the switch out, put a new switch in, and be up and running again. Certainly some valuable information here on the label. Of course, again, it's a sample because it's clear. It does say pump down for emptying. Not all of them say that, but this is definitely pump down switch. And also 120 volt AC, which we can tell by the plug, 60 hertz single phase, and very important is the amperage rating, because this is going to have to handle the amperage of that pump. So we want to make sure with pump switches that they're rated to handle the max amperage of the pump. In this case, it's 13 amps maximum running current. Let's talk about another type of switch here. And from the part number, I could tell there's a U at the end. So this is a pump up switch, 15 foot without plugs. We can tell here we got a bare lead. It says pump up, but let's test it. So I've just got measuring continuity between my two leads. And so normally closed, right? And up is off. So this is a pump up switch or a normally closed switch. Next is a vertical switch. So there's, again, lots of information on the label. But today, let's just focus on what we can tell. So we can tell it's a vertical switch attached to your pump, and pump down only, right? So you only have one option with this. And as the liquid floats up, turns it on and holds it with a magnet until it contacts just heavy enough to turn it off. So this is a pump down vertical switch that is also a piggyback. So how do you check a piggyback with a meter? Well, if you have one of these, it's a little bit easier, and it's really just to identify the hot, black, and to be able to get your meter on it. So we can see here this just little plug, and I could tell the hot is the gold and the silver is the neutral. So I'm just going to plug this on the back here. And again, it's to help me identify which one's hot, because at the end of the day, the switch breaks the hot. And so I just put two color-coded wires here, again indicating which one's hot and which one's neutral. So I can see this is hot. I'm going to connect between these 2 points, the two hots. So again, I just got my continuity meter. I'm going to connect here, again follow that on the other side, and now I'm going to test it. So it should be off and on. And again, it shouldn't go off until the float breaks that connection. Okay, so next is a diaphragm switch, and it basically works based on head pressure. With enough head pressure that turns the switch on, and as it pumps down, it turns it off. And it's preset so that a height of 18 inches turns it on, and then at 12 inches it turns it off. So the only way to adjust that is to move this, which is going to be fixed. So 18 inches above is on, and 12 inches is off. The other thing we could tell, again, we've got a piggyback design float switch and with a breather tube. So one of the things that's unique about the diaphragm switches is that has to be free and clear, because if that gets plugged, it is not going to work properly. So again, let's do a quick check with a meter, using our little device to find the hot. So I'm going to go across the hot. I'm going to press so you can see here the switch is under here. So 18 inches above turns it on, and as it gets down to 12 inches, turns it off. Okay, next is, I want to really focus on the connector, the strap, but this switch is a little different in that it is a piggyback, but it's a 230 piggyback, so we can see it comes in on the side. So your pump is going to be plugged in here, more on the side as opposed to on the back, and we can tell it's 230 with flat blades here. So a little bit different style, still a piggyback, but it's 230 volt. But one of the things I want to focus on here is how do we use the straps? And again, it's in the technical manual, but so we want to bring our wire straight down and then loop it around so horizontally we go through this point here, and the strap goes through the hole in the middle, which tightens everything up. So lastly, there's at least a couple different types of weights to hold your floats down. One is a weight like this, where it comes at a right angle. And then the other is just a simple weight where it goes straight through. So just a couple different styles of weights for your floats or switches. So hopefully that was helpful in reviewing a basic duplex panel with all the bells and whistles, in addition to all the different types of float switches, from pump switches to panel switches, pump up switches, pump down switches, vertical, diaphragm, lots of different types. Again, hopefully that was helpful, and thank you for watching.